Well, as the metamorphic petrology, this metamorphic petrology is concerned, I've told you that there are three kinds of rocks. So these three kinds of rocks, first one is the igneous rock, second is the sedimentary rock, and the final third is the metamorphic rock. Now, these metamorphic rocks are somewhat special because they are converted rocks, right? These rocks are converted rocks. So pre-existing rocks might be anything, right? Pre-existing rock might be anything. It might be an igneous rock, it might be a sedimentary rock, it might be even metamorphic rock, metamorphosed once again. So basically what metamorphic rock actually is a conversion of any pre-existing rock, right? Conversion of any pre-existing rock into another rock due to the action of heat, then pressure, and then time. Okay. So the metamorphic rocks and metamorphism. Okay, this metamorphic rocks and metamorphism. Metamorphism refers to predominantly solid state mineral and textural changes to a pre-existing, which is called as parent rock, or which is actually called as protolith. Okay, this is called as a protolith. Protolith means any pre-existing rock. Okay, pre-existing rock or a parent rock. Okay, pre-existing rock or a parent rock, right? So it is highly dependent. Okay, it is highly dependent on the composition of the protolith. Whatever the composition of the protolith will be, or whatever the composition of the protolith is, the metamorphic rock, okay, metamorphic rock will reflect the same. Okay, metamorphic rock will reflect the same. If the pre-existing rock has larger amount of quartz, okay, has a larger amount of quartz, so it will be reflected in the metamorphic rock itself, right? In the metamorphic rock, just like from sandstone it will form a quartzite. Okay, if there is a limestone, okay, there is limestone which is highly carbonate, it will be converted to marble. Okay, it will be converted to a marble, right? So this metamorphic rock mineralogy is highly dependent upon the chemical composition of the protolith. So whatever the chemical composition of the protolith is will dominate the final product of the metamorphism. Okay, now there are two basic types of metamorphisms. Okay, there are two basic types of metamorphisms. Number one is the pro-grade metamorphism. Okay, number one is the pro-grade metamorphism. Now, what is this pro-grade metamorphism? Pro-grade, right? The name itself indicates pro-grade. Pro-grade means in which the pressure, temperature, and time. Okay, this pressure, temperature, and time, these conditions are increasing. Okay, these conditions are increasing. That means the pressure is increasing, the temperature is increasing, and the time is also considerable. Okay, the time is also considerable. So with increasing pressure, okay, with increasing pressure and increasing temperature, okay, with increasing pressure and increasing temperature, there will be changes in the rocks. Okay, there will be changes in the rock, and these changes in the rocks will be reflected as metamorphism. Okay, these changes will be reflected as the metamorphism, right? So it is suppose that you're creating something or you're cooking something, right? More you cook anything, softer it becomes, right? Softer it becomes. So it is the same thing. Okay, so as the pressure and temperature conditions increase, okay, as the pressure and temperature conditions increase, the metamorphism will occur. Okay, metamorphism will occur. So this will be called as pro-grade metamorphism. Okay, this will be called as prograde metamorphism, right? Now here the mineral replacement and transformation occur due to the processes such as recrystallization. Okay. Recrystallization means whatever the existing crystals are, okay, whatever the existing crystals are, these existing crystals will recrystallize once again. Okay, they will recrystallize once again. Next is neocrystallization. Okay, neocrystallization. What does it mean? Neocrystallization. Neocrystallization means breaking of the bonds of the original minerals. Okay, the breaking of bonds of the original minerals and formation of a new crystal. Okay, formation of a new crystal. So this process will be called as neocrystallization. Okay, this process is called as neocrystallization, and other processes induced by increasing pressure and temperature. Okay, so with increasing pressure and temperature, whatever the processes can be induced, those processes will be induced, and they will take place the changes in the rock. Okay, and this another process, important process, is devolatilization. Okay, devolatilization process. Okay, this devolatilization process or this devolatilization uh, reaction. Okay, now what is this devolatilization? Is the removal of volatiles. Okay, removal of the volatiles. Whatever the volatiles are, volatiles may be in the form of gases, volatiles may be in the form of liquids, volatile may be in the form of water vapor, right? Whichever the volatiles are, these volatiles will be removed off. Okay, these volatiles will be removed off from the original rock. Okay, from the original rock, and they will give rise to a new kind of rock, right? A new kind of rock, and that process is called as devolatilization. Okay, this will be called as devolatilization. So this is the way the prograde metamorphism occurs. Okay, this is the way prograde metamorphism occurs. Now this prograde metamorphism is associated generally with the generally with the depth. Okay, generally with the depth. So with the subduction zones, okay, wherever there are subduction zones near trenches, okay, at the subduction zones, at the trench, in these tectonic settings, okay, in these tectonic settings, generally the prograde metamorphism is seen. Okay, prograde metamorphism is seen in such tectonic settings. Subduction zones, you will encounter at the subduction zones, you will encounter at the trenches, right? Now, in modern aspects of geology, any subject in geology, the tectonic aspect is highly important, right? The tectonic aspects are highly important. In the older literatures, they have not emphasized much on the tectonics of any area or tectonics of any process, but nowadays that any kind of process, right, any kind of process is seen in the light of plate tectonics. Okay, so it will be important for us to go for plate tectonic study, and to study the tectonic aspects of any process which we study, right? Just we are studying about the metamorphism, so we must relate the metamorphism with plate tectonics. In which of the tectonic settings these kind of metamorphism or these kind of processes can occur. Okay, these kind of processes can occur, and these kind of things can be seen, right? Next, the next type of metamorphism, as I have told you, there are two types of metamorphisms, two basic types of metamorphisms. The second type is called as retrograde metamorphism. Okay, it is called as retrograde metamorphism. Now what is mean retrograde? We know prograde. Prograde means increasing pressure and temperature. Okay, prograde means increasing pressure and temperature. Now what about retrograde? What is this retrograde? Retrograde means when there is lowering of pressure and temperature. Okay, when there is lowering of pressure and temperature. So pressure and temperature will be lowered here, right? Pressure and temperature will be lowered here, and due to this, okay, due to this there will be changes in the rock. Okay, there will be changes in the rock, and these will be called as this kind of metamorphism will be called as retrograde metamorphism. Okay, this type of metamorphism will be called as a retrograde metamorphism. Okay, so here lower temperature or pressure mineral assemblages develop that overprint earlier peak temperature or pressure mineral assemblage. What are the low pressure temperature minerals?
Zeolite,
Zeolite, correct.
prehnite, pumpkinite.
Prehnite, pumpelite. Okay, all these minerals are generally the low temperature minerals, low pressure minerals. They form near to the surface, right? They form near to the surface, and such minerals are developed in the retrograde metamorphisms. Okay, they will generate at the retrograde metamorphism, right? प्रेशर एंड टेम्परेचर के कम होने के कारण आपका retrograde metamorphism, right? Now here the volatile components serve as the catalysts in driving the retrograde metamorphism or retrograde metamorphic reaction. So here in the prograde metamorphism, right, in the prograde metamorphism we have seen there is devolatilization, that means removal of volatiles. Okay, devolatilization or removal of volatiles. Here in this case in retrograde there will be addition of volatiles. Okay, there will be addition of volatiles, and these volatile components will serve as the catalyst in the driving the retrograde metamorphic reaction. That means they will enhance the reactions. Okay, they will enhance the reaction, right? So these are the two basic types. These are the two basic types of metamorphism. Okay, the two basic types of metamorphism. Now these metamorphic rocks, okay, the metamorphic rocks are classified based on their composition and texture. Okay, based on the composition and the textures. Okay, so rock composition, as we know, that it is largely determined by protolith chemistry. Okay, protolith chemistry, whatever the protolith was, whichever type of rock it was, it will be reflected in the final rock, in the final product, and it is modified by fluid driven processes that add or remove the constituents, because constituents, they are constantly either they will be added or they will be removed. Okay, constantly they will be added or they will be removed in the process of metamorphism. Just like just take an example of a subduction zone. Okay, take an example of subduction zone. Now there is a rock. Okay, this is a rock, and this has undergone metamorphism at the subduction zone. Okay, so here there will be progressive metamorphism. Here there will be this progressive metamorphism. Progressive metamorphism means there will be subsequent changes in different stages of the depth. Okay, according to the depth. Now this rock, which was highly rich in volatiles, okay, which was highly rich in volatiles, when it undergone the subduction zone, or when it undergone this kind of tectonic setting or high pressure, okay, high pressure, the first thing, it will lose its volatiles. Okay, it will lose the volatile content, correct? It will lose the volatile content. Then second, what will be done? In the successive stages, what will be done? The low pressure and temperature minerals, okay, this low pressure and temperature minerals will be removed, right? These low pressure and temperature minerals will be removed. Why? Because they cannot sustain the high pressure and temperature conditions which has changed in the course of metamorphism, right, from here to here. So whatever, whichever the low pressure and temperature minerals were, they will be removed off. Okay, they will be removed off, or They will not be removed off, but they will be converted to something else. We have we know something which is called as polymorphic transformations or mineral phase transformations. Okay, in the mineral phase transformations, so phases get changed. Okay, the phases get changed just like quartz. Okay, quartz just like alpha quartz converts to beta quartz, right, at 570 degrees Celsius, 573 degrees Celsius to be precise. Okay, alpha quartz converts to beta quartz, that is high quartz convert to low quartz. Okay, high quartz, low quartz, they get keep on converting within each other, right, at 573 degrees Celsius. Now the low pressure and temperature minerals have been removed here. Okay, then more successive stages occurred. Okay, more successive stages occurred, and due to this, what happened? These pressure and these low pressure and temperature minerals which were removed or which were converted to something some else minerals, even these minerals will not be stable. Okay, their stability will also be hampered, right? Their stability will also be hampered. Again, they will be converted to some another minerals by loss of volatiles, by loss of by breaking of the bonds, or by by recrystallization, right? There will be recrystallization, the original bonds will be broken and other bonds will be formed, right? Original bonds will be broken, it will be converted to chemical component and they will form a new component. Okay, and then the stability of such minerals, okay, the stability of such minerals will also be also getting hampered with depth, with increasing depth. Okay, as the depth will keep on increasing, the stability will keep on decreasing. Okay, the stability will keep on decreasing for several minerals. Okay, for several minerals which are low pressure and temperature, which are moderate pressure and temperature minerals, or which are even high pressure and temperature minerals. Okay, highest pressure temperature minerals, okay, high pressure and temperature minerals, they will be stable at this depth. Okay, at this depth, at highest depth, say 50 kilometers. Okay, say 50 kilometers or even more than that. Okay, even more than that. So these will be the changes. Okay, these will be the changes in the chemical in the rock composition or the mineral composition of the rock. Okay, in the rock composition of the rock, just like the we'll see in the facies concept. Okay, we'll see in the facies concept that there is a mineral which is called as omphacite. Okay, there is a mineral which is called as omphacite, which belongs to eclogite fishes. Okay, which belongs to eclogite fishes, and this mineral omphacite is not visible in any of the rock which is less than eclogite fishes. Okay, which is less than eclogite fishes. Why is it so? Because omphacite is only stable at the temperature and pressure conditions imparted by the eclogite fishes. Okay, these pressure and temperature conditions which are imparted by eclogite fishes. In the same way, glaucophane is there, right? Glaucophane, which is characteristically found in the blue schist fishes, and in that blue schist fishes it shows the subduction zone. Okay, it shows subduction zone. Why is it so? Because the glaucophane mineral, which is low temperature but high pressure. Okay, and these conditions are seen in the subduction zones only. Okay, these conditions are seen in the subduction zones only, and it is indicative of the blue schist species metamorphism. So the mineral themselves, okay, the minerals themselves are indicators of the types of metamorphism. Okay, and the depth of metamorphism as well. So rock composition, what is rock composition? Rock composition is nothing but the mineral composition. So this mineral composition and the rock composition is determined by the protolith chemistry, obviously. Okay, whatever the protoliths are, and then fluid driven processes, the process as the depth will as the depth as the whatever the reactions are. Okay, and addition or removal of the constituents. Okay, addition and removal of the constituents. With depth, removal is more, addition is less. Okay, removal is more because at that depth new kind of materials or the minerals are not added in the frequent way. Okay, The metamorphic textures, next. Metamorphic textures are produced in response to temperature and pressure. The textures of the metamorphic rocks, they are found along with the temperature and pressure. Okay, whatever the temperature and pressure are, according to that, the metamorphic textures will be developed. Okay, these metamorphic textures will be developed. Now, the metamorphic rock classification. Okay, the metamorphic rock classification. On the basis of grain orientation, the metamorphic rocks can be divided into two major groups. Okay, there are no two major groups. First is non-foliated, another one is foliated. Okay, the foliated or non-foliated. Okay, what is foliated and non-foliated? First, we'll see non-foliated. Crystals lack a preferred orientation. Okay, the non-foliated rocks. Okay, non-foliated rocks in which there is no preferred orientation. Okay, there is no preferred orientation. That means you may have crystals like this. Okay, you may have crystals like this in any rock. Okay, in any rock. So if in any rock if you observe the crystals, okay, if you have the crystals which are not oriented in a perfect, in a preferred manner, right? If they are not oriented in a preferred manner, just like they are not aligned to any direction or something like that. Okay, it will be called non-foliated. Okay, it will be called non-foliated. Basically, what foliation means? Okay, basically foliation means the layering. Okay, foliation means the layering. Just like I have a book. Okay, if I have a book. So this is a book or notebook, whatever. Okay, so I have this individual. I have this individual pages here. Okay, these individual pages, and these individual pages, okay, these individual pages act as one layer. Okay, one individual page will be one layer, this will be, there will be another layer, there will be another layer, and so on. Okay, and so on. Such layers, okay, such layers, when they are formed, they form a group of such layers will form a foliated nature or foliated texture. Okay, the foliated texture. So stacking of individual layers which have a preferred orientation. Okay, which have a preferred orientation, and that kind of rocks, okay, that kind of rocks are called as foliated rocks. Okay, that kind of rocks are called as foliated rocks. So metamorphic rock classification is based on either the rocks are, if either the rocks are foliated or non-foliated. Okay, if the rocks are foliated or non-foliated. So when describing about these rocks, okay, when describing about the rocks, we go for either foliations or non-foliations. Okay, so either the rock might be foliated or it might be non-foliated. Okay, what is examples of non-foliated rocks? Anybody? Examples of this non-foliated?
Slate.
Slate. Or
Marble.
marble. Okay.
Lies.
Quartzite.
Quartzite.
Quartzite. Or okay, examples of this foliated rocks?
Cyst.
Schist. Okay.
Nice.
Nice.
Elite.
Phyllite. Biotite. Harish, biotite is a mineral. Biotite is not a rock. Okay. So these are the foliated and non-foliated metamorphic rocks. So we'll see. Okay, we'll see here the different rocks. What are the foliated rocks? What are the non-foliated rocks? Uh, and their examples. Okay, I'll give you some of the examples, some famous examples, and I'll go through, take you to the journey of these metamorphic rocks. Okay, just give me a minute. Okay. So first we'll see the non-foliated metamorphic rocks. Okay, the non-foliated metamorphic rocks. The first one is the hornfels. Okay, the hornfels. See, the rocks and the textural terms are similar. Okay, the rock terms and the textural terms are similar here. So hornfels is a rock which has hornfelsic texture. Okay, Hornfels is a rock which has the hornfelsic texture. Now, what is this hornfelsic texture? Hornfelsic texture is a fine-grained, non-foliated fabric that develops by contact metamorphism. Okay, that develops by the contact metamorphism. Now, here the contact metamorphism. This word is important. Okay, so you can call any rock as hornfels, right? You can call any rock as a hornfels if it is formed by the contact metamorphism, right? If it is formed by the contact metamorphism and it is fine grained. Okay, it is fine grained having non-foliated fabric. Okay, it is non-foliated fabric. Fabric means nothing but texture. Okay, fabric is nothing but texture. Okay, so it is derived from fine grained protolith rocks such as shell, mudstone, tuff, or basalt. Okay, so they are derived from shell, mudstone, tuff, or basalt, and the crystals are predominantly equant. Okay, the crystals are equant. Okay, equant means almost of similar size. Almost they are of similar sized. Okay. Then the hornfels says they develop in metamorphic aureoles adjacent to igneous intrusions. Okay, I hope you know the metamorphic aureoles. Okay, this is an aureole. This is completely an aureole. Okay, and this is your igneous intrusion. Okay, this is the igneous intrusion. Okay, so minerals include muscovite, biotite, andalusite, cordierite, plagioclase, potassium feldspars, epidote, amphiboles, and pyroxenes. Okay, so whatever the mineralogy of the protolith was, okay, whatever the mineralogy of the protolith was, it will be carried forward. It will be carried on in the final rock itself. Okay, in the final rock itself. Okay, next, granoblastic rocks. Okay, the granoblastic rocks or granoblastic texture. Okay, the granoblastic texture. Now, what is this granoblastic texture? Whenever we use this word or whenever we use this suffix blastic. Okay, this plastic is used for metamorphic textures. Okay, these are used for the metamorphic textures or in the explanation of the metamorphic rocks. Okay, so granoplastic textures are characterized by large equant grains or large inequant crystals that lack preferred orientation. Okay, the important point in the non-foliated textures is the lack of preferred orientation. So here there will be always lack of preferred orientation, right? So here in the granoplastic texture there will be either there will be equant grains. Okay, there might be equant grains present, or there might be larger inequant grains as well, which lack preferred orientation, which do not have any kind of preferred orientation. They are randomly present. Okay, they are randomly present, but they will have, okay, they will have the grains which are present, and you can observe the grains, or you can observe the individual grains in the rock itself. Okay, so they are also occurring high grade rocks known as granulites. In the granulite rocks also you may see these granuloplastic textures. Okay, that this granuloplastic texture developed during the metamorphism of a wide range of protoliths under uniform stress conditions. So there might be any kind of protolith. Okay, there might be any kind of protolith which can give rise to this granoplastic texture. Okay, which can give rise to the granoplastic textures. Okay, so commonly display the anhedral. The commonly display anhedral subhedral boundaries that reflect combination of pressure solution, recrystallization, and annealing. All these processes, okay, they're acting at the same time. Okay, they're acting at the same time, and they will give rise to this granoplastic textures. Okay, so most commonly developed with minerals such as quartz, feldspar, and calcite. Okay, they are most commonly formed in the quartz, feldspar, and calcites. Okay, so phyllosilicates or other tabular to prismatic minerals are completely or commonly absent. Generally, in granoplastic rocks, you won't see these kind of minerals, just like micas. Okay, this kind of micas. Okay, phyllosilicates to be precise. This is the example of the rock, or this you can see here, the granoplastic texture. Okay, the granoplastic texture. This is the granoplastic texture. Individual grains are identifiable here. Okay, these individual grains are identifiable here, right? And you may see that there is completely a granular appearance. Okay, which do not have any kind of preference. Okay, which do not have any kind of preferred orientation. No preferred orientation is there. Just randomly there are grains, and these grains are randomly oriented, randomly uh, randomly spared. Okay, okay, randomly just like spread over the rock itself. Okay, randomly spread over the rock. Okay. The example of this is metaquartzite or quartzite. Okay, metaquartzite, you may call it metaquartzite or you may call it quartzite itself, no matter. Okay, so it is more than 90% quartz. Okay, it is more than 90% quartz, which is derived from quartz rich sandstone or chert protolith. Okay, majority which is derived from the quartzite, the sandstone, the quartz rich sandstone, which we have classified in the last class as the quartz arenites. Okay, as the quartz arenite. So quartz arenite may be there. This quartz arenite may be there, and this quartz arenite will be metamorphosed. Right, this quartz arenite will be metamorphosed as metaquartzite or quartzite. That's just another name. Okay, accessory minerals may be hematite or feldspars. Okay, so here there will be recrystallization, pressure solution, or intercrystalline plastic deformation mechanisms. Okay, so these are the mechanisms. They're not that important. Okay. Next is the marble. Again, marble, which is a granular rock or granoblastic rock. Okay, marble is a granular or granoblastic rock which is rich in calcite or dolomite. Okay, which is rich in calcite or dolomite. So calcite and dolomite, both minerals are present here. Maybe calcite is more, somewhere dolomite is more. Okay, so they are derived from the recrystallization of limestone or dolostone protolith. Okay, limestone or dolostone protolith. So limestone protolith might be the calcareous protolith might be there, and these calcareous protoliths will finally give rise to the marble. Okay, next, skarns. Okay, skarn deposits, these are again economically important. Okay, these skarn deposits are economically important. They are also called as tektites. Okay, they are also called as tektites. Okay, they are formed due to the contact metamorphism of carbonate country rocks such as limestone or dolostone. Okay, so if say suppose this is a country rock which is having limestone. Okay, which is having limestone, and this rock is acted upon by an igneous intrusion. Okay, by an igneous intrusion. Okay, this rock has been acted upon by the igneous intrusion, and now this zone will have this contact metamorphism. This zone will have the contact metamorphism, and this contact metamorphism will give rise to a specific kind of rock. Okay, to a specific kind of rock which is called as skarn. Okay, this will give rise to skarns. Okay, so skarns commonly contain carbonate minerals such as calcite, dolomite. Okay, and ankerite, silica, whatever these rocks are. Got this? So these are the rocks. Okay, these are the rocks which are present, or these are the rocks which are common. Okay. These are the rocks which are common with the non-foliated textures. Okay, non-foliated textures. Now these are the metamorphic rocks with cataclastic or non-crystalline texture. So there are no crystallinity. Okay, there is no crystallinity. Just like no preferred orientation or nothing like that of the cataclastic. They will have the cataclastic textures. Okay, the rocks which have the cataclastic textures. Okay, so they are composed of fractured angular particles. Okay, fractured and angular particles which are formed in response to brittle crushing of grains during deformation. Okay, majority these rocks are formed due to the faulting processes. Okay, due to the faulting processes. If say suppose this is a fault. Okay, this is your fault. Now during the faulting, okay, during this faulting, there will be mechanical crushing of the fault plane, right? There will be the mechanical crushing of the fault plane. So suppose extrapolate this. Okay, so during the movement, okay, during the movement there will be crushing of this surface. Okay, there is the crushing of this surface, and this crushing of the surface will give rise to angular particles. Okay, it will give rise to angular particle, and these angular particles will be accumulated at the fault itself. Okay, they will be accumulated at the fault itself, and these give rise, okay, these will give rise on the lithification to a rock. Okay, to the rock, that will be cataclasite. Okay, cataclastic rock. Basically these textures, okay, these textures are called as cataclastic textures. Okay, so more the angular particles will be there. Okay, more the angular particles will be there, right? In this, so it develops during dynamic metamorphism. Okay, it develops during the dynamic metamorphism. Okay, and it described with respect to the relative percentage of larger class and finer matrix. Okay, larger class will be there and finer matrix will be there. Okay, so on the basis of that, okay, on the basis of that, we have derived, we have some of the rocks, just like they are called as metabrachia. Okay, metabrachia. Brachia is of variety of kinds. Okay, brachia is of variety of kinds. There is fault brachia, there is metabrachia, there is tectonic brachia, there is volcanic brachia, right? So there are various kind of brachias, and I have told you that what is a brachia. Brachia is anything which has angular fragments, larger grains, angular fragments. Okay, any rock with large grains, any rock with angular fragments will be called as a brachia. Okay, it will be called as a brachia. Whereas if the grains are rounded, it will be called as a conglomerate. Okay, it will be called as a conglomerate. Right. So they are derived from metamorphism of sedimentary or igneous brachias. Right. Metamorphism of igneous or sedimentary brachias. So first there was a rock, metamorphic brachia, the sedimentary brachia was there, or igneous brachias might be there. The volcanic brachia. What is igneous brachia? It is nothing but the volcanic brachia. Okay, so this metamorphism of sedimentary brachias or igneous brachias might be there. So these develop during the dynamic or dynamothermal metamorphism. Okay, these metabrachias are developed during dynamic or dynamothermal metamorphism. Okay, so they contain subangular to angular clasts with diameter more than 2 mm. Okay, and the metabrachias can be composed of single class type or many different class types. This is again a characteristic of the brachias. Okay, this is again the characteristics of the brachias. Next, cataclasite. Okay, these cataclasites. What is this cataclasites? Cataclasites are rocks or the cohesive rocks with cataclastic texture produced by brittle transfer deformation. Okay, produced by the brittle deformation. I've told you in the fault diagram. Okay, there will be brittle breaking of the rock. Okay, breaking of the fault plane. Okay, and this fault plane will generate the uh, the fault plane will generate the uh, sediments. Okay, the angular fragments. Okay, these angular fragments, and these angular fragments. Okay, these angular fragments will form finally a rock. Okay, they will finally form a rock, and these rock will be called as cataclasite. Okay, this will be formed as this rock will be called as cataclasite. So cataclasites form under low temperature, high strain, dynamic metamorphic conditions. Okay, low temperature, high strain, dynamic metamorphic conditions. Okay, these cataclasites retain primary cohesion, which refers to their ability to remain as a cohesive mass during deformation. Okay, so cataclasites are commonly non-foliated. So if phyllosilicates rich are there, they can exhibit foliation, but that is not dominant. Okay, that is not the dominant process, or that is not dominant thing. Right. Then anthracite coal, which you know what is anthracite coal. Okay. Now, next we have to see is the foliated igneous rocks. Okay, the foliated metamorphic rocks, not igneous rocks. The foliated metamorphic rocks. Okay. Now, what are these foliated metamorphic rocks? Foliated metamorphic rocks means those rocks which contains some of the foliations. Okay, the rocks which contain some of the foliations, which are marked by. Okay, the rocks which are marked by the planar alignment of inequal crystals such as tabular phyllosilicates. Okay, which are majoritarily here. There will be phyllosilicates, just like mica, just like clays. Okay, so these will be there. These will be there, which will have the alignment of inequal grains. So there will be like planar or parallel arrangement like this. Okay, planar or parallel arrangement like this. So these foliated textures are commonly associated with dynamic or dynamothermal metamorphism, in which rocks change shape in response to non-uniform stresses, which produce mineral aligned to a parallel to a planar fabric. Okay. Now this foliated cleavage include slaty cleavage, phyletic cleavage, schistosity, gneiss layering, pegmatic layering, and myelonitic foliations. Okay, myelonitic foliations. So what are those? We'll see in their examples. Okay, let's see in the examples. First is the slit. The first one or the first rock is the slits. Now, what are slits? Slits are fine-grained aluminum-rich pellitic rocks. Okay, these are fine-grained aluminum-rich pellitic rocks that possess flat planar cleavage. Okay, it has a flat and planar cleavage, so it will give you flat appearance and it having planar cleavage. So slates basically they are formed due to the metamorphism of shells. Okay, due to the metamorphism of the shell which is sedimentary rock. Okay. So this slaty cleavage consists of closely spaced layer along which the rock breaks or cleaves readily. So like this, closely spaced cleavages will be there. Okay, these kind of closely spaced cleavages will be there, or closely spaced layers will be there, which can be easily broken. Okay, which can easily be broken with just a hammer. Okay, take one hammer, hammer it. Okay, hammer it, and it will be broken. Okay, it will be broken. Now, the layering is defined by the sub-parallel orientation of microscopic phyllosilicate mineral grains. Okay, so sub-parallel orientations might be there. Okay, the sub-parallel orientations might be there, and there will be microscopic phyllosilicate mineral grains. Okay, they are formed due to clay-rich sedimentary protoliths such as shell, siltstone, or mudstone. As I told you, generally it is formed due to the shells. It may be of siltstone, it may be of mudstones. Okay. So it cleavage developed during the metamorphism under non-uniform stresses at relatively lower temperatures. Okay, at relatively lower temperatures, they will form near the surface. Okay, they will form near the surface at a temperature of 150 to 250 degrees Celsius. Okay. Now, here the minerals which are present here, okay, there are with increasing metamorphism such as kaolinite, smectite, zeolite minerals. They decrease in abundance while elite, chlorite, and mica concentration progressively increase. Okay, and accessory minerals include quartz, graphite, pyrite, ilmenite, chlorite, plagioclase, muscovite, and iron oxide. So these are the accessory minerals which are present in the slits. Okay. So all this is the information. Next is the phyllite. Now what is this phyllite? Phyllite is something which has phyletic cleavage. Okay, phyletic cleavage or phyletic cleavage, characterized by large crystal and more wavy surfaces than the slaty cleavage. Slaty cleavage, in case of slaty cleavage, there is smaller or there is closely spaced layers. Okay? There are closely spaced layers. In case of the phyletic cleavage, the cleavage, okay, or the layers are not that closely spaced, but there is more wavy surfaces like this. Okay, there are more wavy surfaces like this. Okay, so there are larger or more reflective macroscopic grains in phyletic cleavage, include a silky or glossy sheen. They are shiny. Okay, they are shiny. They are glossy. Okay, and they are developed by recrystallization of slate and therefore form the same protolith as the slate. Okay, you might be knowing about the diagram. There is one diagram which shows slate, then phyllite, then schist, then gneiss. Okay, the increasing or progressive metamorphism. Okay, the progressive metamorphism of the same one protolith. Okay, uh, progressive metamorphism of one protolith, which gives all these rocks. I showed you the diagram. That is not actually a diagram. That is just the names which are written like this in this book. Okay, don't worry. So smectite and elite clays metamorphose to slightly coarser grained minerals such as sericite, muscovite, talc, and chloride that align parallel to each other and define foliation. So there will be foliations of these mineral grains, just like smectite will be there, muscovite, talc, chloride, all these will be present in a layered arrangement. Okay. Common metamorphic minerals include quartz, feldspar, biotite, graphite, prehnite, and pumpelite. Okay. Now, this is important. Phyletic cleavage develops in response to non-uniform stresses at temperature and pressure that exceeds those that produce slaty cleavage. So, the uniform stress conditions, okay, these uniform stress conditions which will be continued, okay, which have formed the slates, okay, which have formed the slates will be continued right now, okay, will be continued even after the formation of the slate, even after formation of a slate, and these will continue, these will go on, and they will give rise to fillet. Okay, they will give rise to the fillet. Okay, so many fillets display a crenulation cleavage. Okay, the many fillet shows the crenulation cleavage. So what is crenulation cleavage? Crenulation cleavage is like this. कुछ इस तरह से बनता है. This will be crenulation cleavage which cross cuts, okay, which cross cuts an earlier generation of cleavage. Means there is one generation of cleavage present. Okay, there is one generation of cleavage present, and this one generation of cleavage will be cross cut by another generation of cleavage. Okay, will be cross cut by another generation of cleavage, and that will be called as crenulation cleavage. Okay, that will be called as crenulation cleavage. So these phyllites may show you the crenulation cleavage. The next rock is schist. Okay, it's the schist. Now, schist is again progressive metamorphic rock. Okay, progressive metamorphic rock, which is the result of progressive metamorphism of the same protolith. Okay, the same protolith as that of slate and even fillet. Okay, so characterized by a foliation called schistosity. So the form itself, or this texture, the texture or structure of this schist is called as schistosity. Okay, this is called as schistosity, and the schistosity is very common foliation which is defined by sub-parallel arrangement of macroscopic minerals. Now, up till now, we were studying about microscopic. Okay, we are studying about microscopic, so they were not visible, but here these minerals will be visible. Okay, macroscopic platy minerals such as phyllosilicates. Okay, phyllosilicates in closely spaced metamorphic layers. Okay, now this foliation is commonly less regular than the either slates or fillets. Okay, so the mineral assemblage depends on both metamorphic conditions and protolith composition. Okay. Shells like slate and phyllite can develop from pelitic rocks, shell, mudstone, greyback, or altered tuff protolith. Okay, altered tuff protoliths. These schists are produced by dynamothermal metamorphism. Okay, the schists are produced by dynamothermal metamorphism at convergent plate boundaries. Okay, at convergent plate boundaries. I have told you that everything and anything in geology is now being looked once again in the light of plate tectonics. Okay, in the light of plate tectonics. So you must apply this plate tectonic aspect to these conditions as well. So schists are produced as at the dynamothermal metamorphism at convergent plate boundaries. Okay, convergent plate boundaries at the with the temperature of 300 or more than 300 degrees Celsius. Okay, temperature more than 300 degree Celsius. So under such conditions, brittle and ductile deformations may occur. Okay, brittle and ductile deformations may occur. So there might be breaking of the mineral or just the change of the shape of the minerals. Okay. So moderate to high temperatures and uniform stresses induce the development of visible porphyroclasts. There might be porphyroclast. You might be aware of this texture, porphyroblastic or porphyroclastic texture. Okay, porphyroblastic texture, porphyroblastic, this in layering. Okay, or lepidoblastic. Such kind of textures are also there. Right, such kind of layers are also present, or such kind of these textural terms also exist. Okay. Next is the gneiss. Gneisses are characterized by gneissic layering. Okay, they are characterized by gneissic layering. Now, what is gneissic layering? Basically, gneissic layering is arrangement of distinct color bands, arrangement of minerals in the distinct color bands. There will be one light colored layer, another dark colored layers. Okay, light colored layer and dark colored layer. So such layers such layers, they show gneiss. Okay, such layers will show the gneiss, or these kind of layers are called as gneiss layers. Okay, gneiss layers or gneissic layers or gneissic banding. Okay. Now these color bands are most commonly due to alternating light colored quartz or feldspar rich layers and dark colored layers rich in biotite, amphibole, and pyroxenes. Okay, these kind of minerals might be there. Okay, these kind of minerals might be there. So light colored, they are generally by the uh, quartz, feldspar, okay, quartz and feldspar rich layers, and the dark colored might be by the biotite, amphibole, and pyroxenes. Okay. So in addition, major non-ferromagnesian and ferromagnesian minerals, accessory minerals include garnet, sillimanite, cordierite, and corundum. Okay, these kind of minerals might be present. Garnet might be there, sillimanite might be there, cordierite might be there, and corundum might be there. Okay. There is rigid feldspar grains may have been sheared into oval eye shape, which produces organ crystal like this. Okay. like this. These are called as organ crystals or organ eye. Okay, these are known as these are very famously known as organ eye structure or organ eye texture. Okay, quartz grains which are formed in the lens shaped grains are called flashers. Okay, if such in such case there is quartz, okay, there is quartz, it will be called as flasher. It will be called, these grains will be called as flasher. Okay. See here, this you can see the organ. That is not great photograph. Gneiss is developed from lower grade metamorphic rocks as well as from a variety of protoliths including granites, diorites, gabbros, mud rocks, tuffs, and gravaks. Okay, so it can be formed from variety of protolith. Okay, it can be formed of by the variety of protoliths. So the gneisses which develop from the igneous protoliths are called orthogneisses. Okay, from igneous they will be called orthogneisses. Okay, and from sedimentary they will be called as paragneiss. Okay, if a gneiss is developed from igneous protolith, it will be orthogneiss. If it is developed from sedimentary protolith, it will be called as paragneiss. Okay. Next is the migmatite. Okay. Next is the migmatite, which is again a foliated rock. Okay, which is again a foliated rock. In your exam, it can be asked which of the following is a foliated rock. Okay, which of the following is a foliated rock? One of the options might be migmatite, and that will be the correct answer. Okay, that will be the correct answer. Or they can ask you to identify which of the following is not uh, foliated rock. Okay, not a foliated rock, and if in the one of the answers migmatite is given, you might be confused whether migmatite is foliated or non-foliated. So be prepared with this, that migmatites are foliated rocks. Okay, migmatites are foliated rocks. Okay, these are basically mixed rock. Okay, which possess textural and structural characteristics of both igneous and metamorphic rocks. Okay, so it is partly igneous, partly metamorphic. Okay, it is partly igneous and partly metamorphic. So it shows the characteristic of igneous rocks as well as metamorphic rocks. Okay, it will show the properties and the characteristic of igneous rocks as well as metamorphic rocks. Okay. So migmatites typically contain zones of rocks with the outward appearance of granitoid igneous rocks mixed with zones of rocks that resembles typical gneiss. Okay. From outside, it appears to be granitoid rock. Okay, it appears to be a granitoid rock. That means like that of the granite. Okay, like that of the granite, but the zones of typically which appears to be a typical gneiss. Okay, that appears to be a typical gneiss. So these light colored segments consist of quartz and feldspar. Dark colored components are enriched in pyroxenes. Okay. Now this migmatite develop under high temperature conditions in the lower crust. Okay, they are developed in the high temperature conditions in the lower crust. Okay, form via dynamothermal metamorphism. Form via dynamothermal metamorphism at convergent plate boundaries. Okay, at convergent plate boundaries, that in so the processes include partial melting, magma injection, or ductile deformation. Okay, or ductile deformation. So these are the processes which give rise to the migmatites. Right. So these are the rocks. Okay, these are the rocks which are classified or which are present with the classification of metamorphic rocks. Okay, the classification of metamorphic rock, just like foliated and non-foliated. Okay, the foliated rocks and non-foliated rocks. Okay. Now we'll move towards one more concept in metamorphic petrology. Okay, more concept in metamorphic petrology, and which is called as the facies of metamorphism. Okay, the facies of metamorphism. The metamorphic facies. Metamorphic facies, or the facies of metamorphism, whatever you want to call it. Okay. Now, what basically this facies is? Okay, what is the facies concept? Now, the facies is basically assemblage of minerals. Okay, the assemblage of minerals. Now, why this assemblage of minerals? Because, as I've told you, that with progressive metamorphism, okay, with the progressive metamorphism, the minerals and the constituent of the rock alters or changes, right? So this assemblage of minerals according to pressure, temperature, and depth. Okay, according to pressure, temperature, and depth, these assemblage of minerals changes. Okay, the assemblage of mineral changes, or the assemblage of minerals alters or modifies. Okay, these modifications, are seen. Okay, these modifications are seen in a series of manner. Okay, in a series of manner, and these series of manner is called as the fishes. Okay, this is called as fishes. So in total there are 11 fishes. Okay, in total there are 11 metamorphic fishes which have devised by the geologists. Okay, these are, the first one is a zeolite fishes. Okay, the first one is the zeolite fishes, then prehnite pompiliate fishes, then green schist fishes, then amphibolite fishes, and the granulite fishes. Okay, zeolite, prehnite pompiliate, green schist, amphibolite, and granulite. So these are the fishes. Then there is a blue schist fishes, eclogite fishes. Okay, then here albite epidote hornfels fishes, hornblade hornfels fishes, pyroxene hornfeld fishes, and sanidinite fishes. Okay, so in total there are 11 fishes. Okay, these show a trend of progressive metamorphism. Okay, these show the trend of progressive metamorphism. This is low pressure and temperature fishes. Okay, this is your highest pressure and temperature fishes. Okay, highest pressure and temperature fishes, right? These four are the fishes of contact metamorphism. Okay, these four are the fishes of contact metamorphism. These characteristically show subduction zone setting. Okay, subduction zone settings. So these facies diagram, okay, this facies diagram will give you the insight about all these different types of processes. Okay, so this each and every facies, okay, each and every facies has its own characteristic assemblage. Okay, its own characteristic assemblage. What we have to do is to learn the name of fishes and its characteristic assemblage. That's it. Okay, it will serve the examination purpose. Okay, it will serve the examination purpose. So take the name of the fishes and its characteristic minerals. Now these characteristic minerals are given in this table. Okay, these are given in this table. So zeolite fishes. Okay, this zeolite fishes. In this we have zeolites. Then which zeolite? Especially lamontite, veracite, analcime. Okay, analcime. All these zeolites are generally common in the zeolite fishes. Okay, they are common in zeolite fishes. Okay. Then in prehnite pompelliite, you will have prehnite plus pompelliite plus fluorite, albite. These kind of minerals are there. Okay. In a green schist, okay, green schist fishes, green colored minerals will be there, right? In the green schist fishes, there will be green colored minerals. So fluorite, albite, epidote, then actinolite, quartz may or may not be present. Okay, quartz may or may not be present. In amphibolite fishes, okay, in amphibolite fishes, hornblende, plagioclase. So plagioclase can be either oligoclase or andesite, or may not be garnet. Then in granulate fishes, you have orthopyroxene, clinopyroxene, then plagioclase plus or minus garnet. Okay, so in granulate, you have both the pyroxenes. Okay, in granulate, you have both the pyroxenes. There might be a question that name the fishes in which both pyroxenes are seen, clinopyroxene and orthopyroxene, both the pyroxenes are seen in the granulate fishes. Okay, here in the blue schist, glaucophene, the characteristic mineral. Okay, the characteristic mineral glaucophene will be found in the blue schist fishes. Again, lawsonite or epidote zoisite, albite, chloride, garnet. This may or may not be present. Okay, this may or may not be present. Next, eclogite. Eclogite, just a minute. In the eclogite, you have pearlspite garnet. Okay, pearlspite garnet. What are pearlspite garnets? Pearlspite,
Pyro.
pyro. This is almandine, and this is spessartite. Okay, and omphacite pyroxene. Okay, this omphacite pyroxene, omphacetic pyroxene or omphacite, okay, is characteristically found in the eclogite fishes. Okay, characteristically found in the eclogite fishes, and more importantly, there is no plagioclase. Okay, more importantly, there is no plagioclase. Okay, now the contact fishes or the fishes of contact metamorphism, which we have seen, that albite, epidote, hornfels, hornblende, hornfels, all these fishes. Okay, so mineral assemblies in mafic rocks do not offer substantially from those corresponding regional or higher pressure. Basically, these fishes, okay, those fishes are named by their mineral themselves. Okay, named by their characteristic mineral themselves, just like AE hornfels or albite epidote hornfels. There will be albite, there will be epidote. Hornblende hornfels, there will be hornblende. Pyroxene hornfels, there will be pyroxenes, and sanidinite, there will be sanidinite. Right? There will be the sanidinite. So this is These are the mineral assemblages. Okay, these are the mineral assemblages. You must learn this table thoroughly. Okay, you must learn this table thoroughly so that if ever there is a question from this table, okay, and majority of the questions from the facies of metamorphism will be asked from this table itself. Okay, they won't ask you the pressure and temperature range. They won't ask you about anything which is way vague concepts or very larger concept, but they will ask you about the mineral assemblage. Okay, they will ask you about the mineral assemblage of any of the minerals. Okay, they'll ask you the mineral assemblage of any of the any of these species. Okay, any of these species. So take any species and learn their characteristic minerals. Okay, characteristic minerals. Now, next concept which is related to this. Okay, next concept which is related to this is facies series. Okay, so facies series. Now, these facies, if they are these facies are basically found in a series. Okay, they are found in a progressive metamorphism. Okay, found at the progressive metamorphism, and during this progressive metamorphism, what you will see a series of different facies forming. Okay, facies of different series of different facies which are forming, and these series are called as facies series. Okay, these are called as facies series. So there are 5 facies series. Okay, there are 5 facies series which are distributed or which are classified in three headings. Okay, under 3 headings. These are low pressure temperature series, moderate pressure temperature series, and high pressure temperature series. Okay, low pressure temperature series. There are 2 facies in this category. The low pressure temperature contact facies series. Okay, contact facies series, and higher somewhat higher in this somewhat higher pressure temperature Buchan facies series. Okay, this Buchan facies series, or which is also called as Abukama facies series. Okay, this is also known as Abukama facies series. Okay, in the moderate pressure temperature conditions or moderate pressure temperature series, it will be Barrovian facies series. Okay, it will be Barrovian facies series. And in the high pressure temperature series group, it will be San Bagawa facies series and Franciscan facies series. So there are again 2 facies series. Okay, there are 2 again facies series, San Bagawa and Franciscan facies series. So Franciscan will be the highest facies, highest grade or highest pressure temperature facies series. Okay, and how to learn this? From this diagram. Okay, you can learn this from this diagram. Okay, these are the facies series, right? These are the facies series, or here. Okay, this will give you a more detailed insight. Okay, it will give you more detailed insight of this same diagram. Okay, so this facies series, okay, the facies series include the facies. In facies, what did we focused upon? We focused upon individual minerals, right? We focused upon individual minerals. So facies was a group of minerals. Okay, facies was a group of minerals. In the case of facies series of individual series is the group of facies. Okay, it's a group of facies, just like contact facies. Okay, the contact facies series. Contact facies series starts from this zeolite. Okay, zeolite to cyanidinite. Okay, zeolite to cyanidinite. So in between it has AE hornfels, which has hornblende hornfels, it has pyroxene hornfels. Okay, which has pyroxene hornfels. So it has 4 to 5 facies. Okay, it has 4 to 5 facies. It has zeolite, it has then albite epidote, then hornblende, then pyroxene, and then cyanidinite. So these 4 5 facies are there in a one facies series, which is called as contact facies series. Okay, which is called as the contact facies series. Somewhat higher temperature and pressure conditions are acquired in these same conditions, so the facies get changed. Okay, so started from zeolite, entering into prehnite pompiliate, okay, then here green schist, then amphibolite, and all the way towards the granulite. Okay, all the way towards granulite. So this will become your Buchan facies series. Okay, this will become your Buchan facies series, or which will also be called as Abukama facies series. Okay, then starting with again zeolite, prehnite pompiliate, green schist, amphibolite, again till granulite, but the but the arrow, okay, this arrow is steep. Okay, the arrow is steep, which indicates there is higher pressure, there is higher temperature, but the minerals which are forming are similar. Okay, minerals which are forming are similar here. Then comes the San Bagawa facies series. Okay, then comes the San Bagawa facies series. Now what is San Bagawa facies series? It includes zeolite, prehnite pompiliate, then it enters, okay, then it enters this blue schist zone and comes to green schist. Okay, so zeolite, prehnite pompiliate, blue schist and green schist, like this. Okay, so this will be called as San Bagawa facies series. And the last is Franciscan facies series. Okay, the Franciscan facies series, which again starts from zeolite, prehnite pompiliate, enters into blue schist, but apart from going to green schist, it enters the eclogite zone. Okay, it enters the eclogite zone and forms the high grade rocks or high grade pressure and temperature conditions. Okay, so this will be called as Franciscan facies series. Okay, so the question might be asked, okay, question might be asked by having the individual facies, okay, by having individual facies, or it may ask, okay, the question may ask you either with the individual facies, or they will ask you that which of the facies is low temperature facies, which of the facies is high temperature facies, which of the following facies is moderate temperature pressure facies. So these kind of questions are pretty common in such diagrams, in such concepts. Okay, got this? समझ में आया? सुबह करे सब?
यस सर, आ गया समझ में.
Okay, so this is all about the metamorphism. Okay, this is all about metamorphism, what which we had to study for our examination purpose. Okay, so I'll end the class here itself, right? So this is it for today. So the petrology portion